So this is kind of your introduction to the ideal gas law. Now, first thing I want to point out to you is this. You have the ideal gas law right here. And we kind of looked at that in the last video. We looked at it yesterday in a video. We're going to look at it more today. So this is a relationship that holds true for gases at room, kind of just room pressure and temperature kind of stuff. Now, you're going to need R, and R is the 0.08206 liters times atmospheres divided by moles and divided by Kelvin. If you need to convert from millimeters of mercury to atmospheres, there's the relationship. You've also got that in your notes from yesterday. Also, if you have degrees Celsius, you just need to add 273 to get Kelvin. Or if you have Kelvin, you just need to subtract 273 to get Celsius. So here is the first problem. This is where you're going to be starting to solve this kind of problem. From the description in the problem, it says, what is the pressure? So I'm going to put a question mark there. I'm also going to write pressure, volume, moles, and temperature. Remember, you get a point for organizing your data like this. I think the easiest way is to write it clear over here to the left. That's how I start my problems. I see here 0.622 moles. So we put that in, 9.22 liters, and 16 degrees Celsius. We put those numbers here. 9.22 liters, 16 Celsius though. You know you can't use Celsius. You have to use Kelvin for the reasons we described this morning. The kinetic energy and Kelvin temperature is a linear relationship that must be used. So that's 298 Kelvin. Now, we're going to write down the ideal gas law, right? And the ideal gas law is here, PV equals nRT. But we need the pressure. The pressure is what we have the question mark by over there. So we're going to solve this for pressure. That means we have to move volume across and down, divide by volume, so we end up with nRT over V. nRT divided by V. I'm not sure what happened to my mark like this. Oops. There we go. There's a fine line that divides the numerator from the denominator. Did you know that? It needs to be there. Okay, that's the fine line. We substitute in the numbers from our data table. Those are the numbers we have clear over to the left. We put those numbers in. We put them into our calculator, and we get 1.59. Oops, now I need my highlighter back. 1.59 atmospheres. That is the pressure in that container. So that is your introduction. Let's look briefly at the next problem. I'm going to just leave it right here with you because this is the information you need to get started. Yes? We had a glitch in the matrix and the screen stopped projecting. Okay, so I'm going to stop my